So we're going to start by finishing up the second part of 1.3. And we're just going to start with a domain and range problem. We're going to start by typing something into the calculator, and I want to see if we can figure out the domain and the range. So let's type in 16x minus x, press the caret, and plus 3. Notice now your cursor is now in the exponent. If you keep typing things, it's going to stay in the exponent. If you want to come back down, because you have to type in something else, like maybe you need to put +1, press the right arrow, and it'll bring your cursor back down. Now I could do +1, and it's not in the exponent. Okay, somebody had mentioned that in last night's homework. All right. You just press the caret, and then press 3. And that'll put your cursor up in the exponent. Yep, right below clear. All right, let's start with a zoom 6. That's always a good place to set your window, and then just see what this looks like. So this is a cubic function. And I'll give you a hint. A cubic function is always connected. You never have to lift your pencil to draw it. So do you think that's a good window? No, because it's going off the screen a little bit. With a cubic function, it takes some turns, and you should be able to see those turns. So to be able to see those better, what do I need to adjust? The x min and max or the y min and max? 2 of them are okay, 2 of them are not. Yeah? Yeah, I would set these a little lower and higher. How much lower and higher? I don't know. Let's try -30 to 30. If that's not enough, I'll do more. That's good. So that's a good complete graph for that problem.
How do you know what to guess?
Practice. Yeah. I mean, if you guessed like -10,000 to 10,000, then you'd probably see your graph all of a sudden get really squished. That'd be way too big. So it's just, we'll learn a few tricks here and there, but in general, it's a lot of just practice. One thing you could check is you could check your table, and you could try typing in values, like 0, okay, goes through the origin. How about at 2? Oh, wow. At 2, I'm all the way up to 24. All right, so that tells me I got to go to at least 24. About 2.5. Well, still around 24. 3? Okay, now I'm coming back down. So by going up and coming back down, I know that I just found this area. It looks like 24 is about as high as it went. I tried 30, so that was perfect. So now, domain and range. What numbers could you plug in for x in that formula? And remember the 2 things that can happen that you don't want to happen. Yeah. You can plug anything you want in. Would you ever be dividing by 0 in that formula? Would you ever take the square root of a negative? Then you can plug anything in you want. So the domain is all reals. Again, with our notation, it's -infinity to infinity. Parenthesis on each end, because you can never actually reach those values. Now the range is how high and low the graph is going to go. What do you think the range is going to be here? Yeah?
All real numbers.
It's also all real numbers. If you're not sure, try plugging in like an x value of 10, which is all the way on the right. Watch how far down the graph is at 10. It's at -840. So we know if it's at negative 840, it's probably just going to keep going down. And same thing here. You could try negative 10 and see what happens when you go to the left. This graph is going to go way up. It's at positive 840. It's symmetrical. Right, so this range is also all real numbers. It goes up and down forever, and it does go left and right forever. Any question on that? All right, so let's try this. It says a rectangular pool has dimensions of 30 by 50. And there is a sidewalk around the pool. The sidewalk is the same width all the way around. The area of the sidewalk is 600 square feet. What is the width? Okay, let's see that. So there's a lot of different pieces of information there. What do you think would help us to see all this information better than having it written as sentences? Yep. Yeah, let's make a diagram. So the first thing I'd like to do, I want to draw a rectangle that represents the pool, 30 by 50. So I'm going to put a rectangle. Not a square. Let's try a rectangle. 30 by 50. And there's a sidewalk around the pool. And it's exactly the same width all the way around. So let's put the sidewalk around the pool like that. So here's my pool. And the pool was 30 by 50. From there over to there. What's that?
The pool itself is 30 by 50.
I think so. Yes, the pool itself is 30 by 50. Yeah. What does it say the width of the sidewalk is? X. So, I'm not going to mark it everywhere, but that width of the sidewalk is X all the way around. All right, so first thing I want to think of is kind of a general idea of how I could find the area of the sidewalk. I want you to think of the area of the sidewalk in terms of two other rectangles in that picture. Anyone see how you could find the area of this space in terms of the two other rectangles that are in this picture? We'll say in terms of like the red rectangle and the black rectangle. Yep.
Can you find the area of the pool?
Yep. Find the area. We're going to find the area of the pool. Yep.
And then subtract that from the area of the sidewalk.
Yeah. So the area of the sidewalk is going to be the area of, I don't know, I'll call it the red rectangle minus the area of the pool. So now, we know the area of the sidewalk. What does it say the area of the sidewalk is? 600. So we can fill that in. Area of the pool, leave some space. What's 30 times 50? 1,500. Now we just need the area of the red rectangle. Well, kind of already assumed you knew this when I did the area of the pool, but what's the formula for the area of a rectangle? Yep, so base times height, or length times width, however you want to think about it. We need the length and the width of the red rectangle. How long is that part right there. And I'll give you a hint. It's 50 plus 2x. It's the pool plus the width of the sidewalk on each end. How about height? It's the same idea. It's 30 plus 2x. Now, solve for x. So we set up a diagram. We're done with that. We set up the equation. Now we have to solve it. First thing we should do is this. Came up in the homework. We're going to have to FOIL or distribute that out. 50 times 30 is how much? We just did that calculation. That's actually going to cancel out in a second. So 1,500. 50 times 2x is how much? That's 100x. And what's 2x times 30? 60x. So 160x. And what's 2x times 2x? 4x squared. Minus 1,500. So we can cross those out. So now you're left with this. I'm going to put it in this order because this is normally how you would write one of these things. What kind of equation is that? And it has to do with the highest exponent being a 2. So if the highest exponent was a 1, it would be linear, but it's not linear. Exponential is when the exponent is a variable. We'll talk about those much later. But this is a little simpler than exponential because the exponent is still a number. Yeah? That's a quadratic. So we have a quadratic equation. You can solve that any way you know. You can try to factor it or use the quadratic formula. If you want to try to factor it, you're supposed to get it equal to what number? 0. So you should bring the 600 to the other side. And if I was going to try to factor this, there's something I would do first that would make these numbers a little smaller. Anyone see what you could do? Yeah. You could divide by 2. You can even go a little bigger. You can divide everything by 4. Is that necessary? No, but it makes the numbers a little easier to work. All right, so now we want to try and see how to solve it. I think I said it earlier. But what are the couple different methods you can use to solve that type of equation? What's one way you could try? Yeah.
Isn't it? It's like something that adds to middle number or multiplies the middle number and adds up to the last number.
It multiplies to the 150 and it adds or subtracts to 40. So that'd be factoring. I don't think this problem is going to be factorable. So is there anything else I can do besides factoring to solve that type of equation? Yeah?
You could use the quadratic formula.
You could, yeah. You can use the quadratic formula. So in this case, that's going to be the way we have to solve it. What would A be if we were going to use quadratic formula? Yeah.
1.
1. And B? How about Jared?
Would it be 40?
40. And C? Yeah.
Negative 1.
negative 150. So once we plug that into the quadratic formula, we will have our answer. Yes?
This is a dumb question. I completely blanked on what we're trying to find right now.
What are we finding? The width of the sidewalk.
Okay.
We're solving for x.
Okay, thank you.
So once we solve this, we will know the width. So just a reminder, in case you don't remember the quadratic formula, not really something we spend a lot of time learning, because that's really more algebra 1. All right, let's fill it in, see what we get. So negative 40 plus or minus the square root of 1600 minus 4 times a times c. Well, 4 times a is 40 times c is negative 150. All divided by 2. Just double check, make sure I put everything in right. So negative 40 plus or minus 1600 minus, oh, wait a minute, 4 times a, yeah, you're right, add an extra 0. Thank you. That's 4 times a. Well, a is just 1, so 4 times 1 is 4, not 40. Yes, thank you. All right, so that's negative 40. This is minus a minus, so that's going to turn into a plus. What's 4 times 150? 600. Again, minus a minus makes that a plus. This is why we couldn't factor it, because the square root of 1600 plus 600 is not a nice number. I'm not sure what it is, so use your calculator. Negative 40 plus the square root of 2400 divided by 2.
We want to be 2200?
Yes, 2200. Thank you. Negative 40 plus the square root 16 plus 6 is 22, not 20. 2200 divided by 2. So we get 3.45 for the width. Now, when you do a quadratic formula problem, how many answers are there? 2. The sidewalk can't be 2 different widths. What do you think if I did the other answer out, negative 40 minus the square root over 2? What kind of number do you think I would get? I'd get a negative. So you don't even have to worry about the other answer, because it just wouldn't make sense in this problem. You could try it. But that's the width of the sidewalk. 3.45 feet. Okay, so that covered quite a bit. Covered, making the diagram and then a real quick kind of quadratic problem. But you should be pretty comfortable with solving the quadratic. And that's why I put the formula up, just in case you didn't remember it. But you should know that. Okay, any question on that? All right, you're going to have one like that in the homework. If you get stuck, just look back in the notes and look at how we set up the original problem. It's literally just going to be different numbers other than like a 50 and a 30. That's all that changes.
What did you plug in? Because I got the wrong answer when I plugged in my calculator. I don't know if I plugged it in.
I plugged it in just like that. I did the numerator first, and then I hit enter, and then I did the denominator.
I tried to do it all in one.
Yeah, if you want to do it all at once, you're going to need parentheses, so the calculator does order of operations correctly. But I generally do it in 2 different steps. All right, so that was kind of a quick little review of solving the quadratic. The next thing we're going to look at is a formula for what's called projectile motion. If you needed that on a test, I would give you that formula. But this is a formula that tells you how high an object will go if it's traveling in projectile motion. An example of something that's projectile motion, think of shooting like a cannon and the ball goes through the air. That's projectile motion. There are two things that they always have to give you in a projectile motion problem. And I just circled them. The first one, v sub 0, that's the initial velocity. So if you shoot a cannon, how fast is the ball going the second it leaves the cannon? That's the initial velocity. The other thing they have to give you is the initial height. Did you shoot this cannon like on the ground? Or is this cannon up on a hill? If the cannon's up on a hill, then the object already has some height, and you're shooting it off the hill. But they have to tell you those two things. In the units, like if you take physics, you might learn a different formula that has a different number instead of 16. The reason the 16 is there is because of the units we're using. Feet and seconds. Let's try an example. Everybody have the formula? Okay. So this says that we're shooting a rocket, cannon, rocket, whatever, same thing. It's shooting straight up from ground level. So this gives you a hint at the initial height. If it's ground level, how high do you think it is? 0. So we have a 0 for the initial height. Makes it a little easier. And the initial velocity is 64 feet per second. So let's write down the formula for this, plugging in that information. So the height as a function of time is going to be negative 16 t squared plus v sub 0 t. What's the initial velocity in this case? 64 t. Now normally I would put a plus and then I would put the initial height on the end. But there is no initial height. It's 0. So you don't need to put plus 0. So here's your equation that models the rocket. Now it's a quadratic again, but we've already done some stuff with quadratics. So what we're going to do now is we're going to use the calculator to do this entire problem. I'm not going to use quadratic formula this time. If we get to a point where we would need to, we'll use the calculator. At what time will the rocket be 50 feet above the ground? Where would that 50 feet get plugged into? Would that get plugged in for t or s of t? S of t, yeah. S of t is the height. T is the time. This is a height. 50 equals negative 16t squared plus 64t. This is exactly the same type of equation you just solved. You'd have to set it equal to 0 by bringing the 50 to the other side and try to use quadratic formula. But let's do it a little different. Let's do an intercept. If I want to do an intercept, we learned a little about that yesterday, what would I put in y1? So it's going to have to do with this. Yeah?
Y equals, are we talking about on the calculator?
Yep.
Okay. You put y1 equals 50.
50.
Y2 equals negative 16t squared plus 64t.
Negative 16 Sorry, I just can't keep up. T squared. We have to use x. That's the variable. I know we use t. Plus. Yeah. Now, we don't know how high the rocket goes, but we want to know when it hits at least 50 feet. So my Ymax should be at least 50. It might even go higher than that. So I would say, to be safe, let's set our Ymax at 100 feet. What's the lowest that this object can go? 0. It's not going to go below ground. What's the smallest amount of time that can go by before we launch the rocket? 0. You can't have negative 10 seconds. And then the x max would have to do with how long it's in the air for. That I don't know. So I'm just going to leave it at 10 and see what happens. I'm going to hit graph. There's my line that represents 50. There's the height. So we can see that it definitely goes above 50, a little bit. So how many times is the ball exactly 50 feet high? Twice, on the way up and on the way down. It hits 50 feet twice. So we have to calculate both of those intersects. So let's do second calc intersect. There's only 2 curves on the screen. Okay, so there's only 2 curves on the screen. So we definitely want to use the blue one. So hit enter. And we want to use the red one. So if you move your cursor, it is on the red one. I'm just off the screen. But if I move my cursor enough, now I can see it came back on the screen. Hit enter on the red one. Now this is where the guess is important. Wherever you put the guess closer to, that's the intersection point it will give you. I'm going to do the one on the right first. And I got an intersection point of 2.94. So now on the way down, this object will have a height of 50 feet at 2.94 seconds. So what time will it be 50 feet off the ground? The second time is 2.94. Does anyone have the first time? 1.06. That's on the way up. Those are the 2 times when it's 50 feet off the ground. Any question on how I found that with intersect? Could have used quadratic formula, and I would have gotten those 2 answers from the quadratic formula, the plus or minus. All right, and the last part asks, what is the maximum height of the rocket, and when do we reach that height? Well, let's just look back at this picture again. The maximum height of the rocket is right there. It's when the parabola hits its maximum. So let's go back to the calculator. And the maximum is something you would want to calculate. So let's do second calc. And does anyone see an option there that would be appropriate? 4. Let's try option 4. Second calc, press 4. Now, the calculator is going to ask you 3 things. Left bound means pick somewhere, whoops, second calc, option 4. See how the font here is in blue? That means it's trying to calculate the maximum of the blue. I want to be on the red one. I don't want to be on the blue one. So just hit the up arrow. Now it's on the red one. That's what I want to find the maximum of. The first question says, pick a point that you know is somewhere to the left of the maximum. What we're going to do is kind of narrow down for the calculator where it is and hit enter. Pick a point that you know is to the right of the maximum and hit enter. On your screen, it should now look like that. You've told the calculator to look between those two dotted lines to try and find the maximum. The last thing we have to do is a guess, which isn't really important because there's only one maximum in there. If there was more than one, then it would find the one it's closest to. But there's only one. So at what time does this object hit its maximum height? It's at 2 seconds, right? It's 1.9 repeating. It's basically 2 seconds. And what is the maximum height? Yep, 64. Now, depending on your calculator, you might see 2.00000000003, or you might see 1.99999999995. You might see something a little different. When I say a little different, I mean like 1/1,000,000th of a number different. It's just because of the type of calculator you have. That's all. But that's the answer. 2 seconds, it hits a height of 64 feet. Any question on that? So we're not going to do the 1.3. Let's look at the last thing here, and then we're going to save 1.4 for, save that for a minute. So the last thing is what's called a piecewise function. Okay? In a piecewise function, you basically graph two or more graphs at the same time. It's basically where I use a different formula depending on the value of the domain. Like let's say I was selling tickets, and I had 3 different prices for tickets. If you were under 10 years old, tickets are $1. If you were between 10 and 18, tickets are $2. If you're over 18, they're $3. So if you said to me, I have 3 adults over 18 that want to buy tickets, how much is it going to cost? I first have to figure out which formula do I use. And the answer to that would be the one that was for people that were 18 and older. And I would plug in how many adults you have into that formula. If you said, well, I've got somebody that's 15 years old and they want a ticket, I'd say, okay, I have to find the formula that applies to 15-year-olds. So it's where you have different functions and you have a different formula depending on the value. And I'll show you a concrete example. In my example, I'm going to break the domain into 2 parts. I'm not going to do 3 parts. I'm going to do 2. So here's my formula. And I think all I'm going to have you do with this, I'm just going to have you graph it. That's it. Just graph it. This formula is split up into 2 parts for a piecewise function. If you give me a value less than 1, I'm going to use a certain formula to calculate the answer. If you give me a value that's greater than or equal to 1, I'm going to use a different formula. So it just takes your domain and it splits it up, so you use a different formula depending on the value you type in. So what I want to do is show you how to graph this type of function on the calculator. And that would be the last thing. It's pretty similar to how you would graph anything. The only thing that's different is you have to give it a condition. You tell it to graph something, but then you tell it to only graph it here, like when x is less than 1. Don't graph it anywhere else. This is how you do it. So if you have anything typed in, just clear it out. The big thing is parentheses. if you're going to type in something that's a piecewise function, put your formula in parentheses, just like that. Next to that, you put in where you want the calculator to draw that. I only want it to draw it when x is less than 1. So, in parentheses, put a parenthesis, put x, and I haven't shown you where the less than symbol is. That's under test. You press second, and it's the third button down. So second math. And it'll bring up a list of all your inequality symbols. Could you find them in the catalog? Yep, you could do it that way too, but it's probably going to take longer. So second, test, option 5, put in a 1. Now on Y2, do the same thing. In parentheses, type in x cubed minus 4x. And next to it, put the condition when you want to draw that one. That's when x, second math, greater than or equal to is number 4. And now the calculator is going to draw 2 different pictures on the same graph, but it's going to draw the top one when x is less than 1, and it's going to draw the bottom one when it's greater than or equal to 1. Right, let's do zoom 6 and see what it looks like. So notice, all of a sudden, that top one just stopped. It should be a parabola, x squared, but it stopped at 1. It started putting this blue line on the axis. We can ignore that. The calculator doesn't know what to do when you're greater than 1 on this one, and I wish it just didn't do anything, but that's what it does. So that is what your graph looks like. To be clear, pretend like the axis is right there, and you can't even see those colored lines. Now, technically, on the end of the blue one, do you include or not include 1 on the blue graph? You don't. Technically. Do you include or not include 1 on the bottom graph? You do. So that, the calculator can't do that part, but that's technically what that graph should look like. It's a parabola up to, not including 1, and then from 1 on, it's a cubic. But that's called a piecewise function. And that was the last thing for today.
And if you were to take the domain, it would still be all real numbers because it does eventually include.
Yeah, the domain is all real numbers because no matter what number you give me, I have a place to put it. I have a formula I can fit it into. Any number you could give me is either less than 1 or greater than or equal to 1. It would fit somewhere. Yep, the domain is all real numbers. So that was the second part of 1.3. I think that's a good place. We'll stop with that. So that is the homework on 1.3. If you want to write page 42, you can write it. You do not have to do page 42. That's going to be part of Monday night's homework. But this is all, this is due Monday. So I think it's like 10 or 11.